Hello and welcome to our video Ratios 1. So this is our first video on ratios, and today we're going to look simply at what a ratio is and how we can simplify a ratio, or how a ratio can be changed. So as always, we're going to start with the definition. What is a ratio? Now a ratio, as you can see being written on the screen now, is a comparison of two or more quantities. So a ratio is used to compare the size of different quantities. Okay, so let's look at what a ratio is. It looks, as we're going to start with two numbers, we've got two dots, as you might say 4. Now we read a ratio using the word 2. So we say 3 to 4. And that simply means that when you've got 3 of something on one side, on the other side you will have 4. So for every 3 triangles on one side, we would need to have 4 triangles on the other side. It can also, of course, be used to compare different items. So we could have, for every 3 circles or dots, we have 4 squares. So it all depends on the question or the situation in which you're dealing with as to whether the items are the same or whether they are different. But the ratio is simply there to show the comparison of how big the 2 sides or how big the 3 sides are in comparison. Okay, let's look at a ratio 5 to 6. So we're going to show this ratio by drawing out little squares. So on the 5, we're going to draw out 5 squares, and on the side with the 6, we're going to draw out 6 squares. So we're showing the ratio in a diagram. Now what we're going to do is we're going to think about how we could change the ratio, because the ratio is showing the comparison, so the numbers inside it can change without changing the comparison. So what we're going to do is very similar to dealing with equivalent fractions. We're going to double both numbers in the ratio. So we're actually going to say, well, let's double the 5 to make 10 and double the 6 to make 12. And what that's showing is if for every 5 on the left, we would need 6 on the right. So if we had 2 lots of 5 squares on the left, we would need 2 lots of 6 squares on the right. So the ratio numbers have changed, but it still shows the same comparison. Now most of the time that you will do this, you will actually be making the numbers smaller. So you will be doing what we would call simplifying. Now simplifying, apart from making things simpler, in this situation is all about reducing to the smallest numbers. So actually what we want to do is we want to make sure that the numbers in our ratio are as small as we can make them. So let's start with a ratio 16 to 8. Now I know that 16 and 8 are both even numbers. Now if that's the case, then of course I can divide both of the numbers by 2. So I can halve each number and I get 8 to 4. That is a simplified version of 16 to 8. However, just been spotted that of course 16 and 8 are both in the 4 times table. So we can also divide them both by 4, which leaves us with an even more simplified ratio of 4 to 2. Further exploration has suddenly realized that the gap between 16 and 8 is 8, which means they're both divisible by 8. So 16 divided by 8 will give us 2, and 8 divided by 8 will give us 1. Clearly that is the answer because it has got the smallest numbers in the ratio. What do we notice? The number we divided by was the biggest. So to simplify, you need to divide by the biggest possible number. So we're going to show you a couple of ratios now and think about how you might simplify these as far as possible. So again, pause the video if you want to try without being told. Let's start with 12 to 3. Times tables, 3 is only in the 3 times table. Is 12 in the 3 times table? It is, so that means we can divide by 3. So 12 divided by 3 will give us 4, and of course 3 divided by 3 will give us 1. Now we look at 24 and 16. They're both even numbers. They're both in the 4 times table, that's possible. But also the gap between them is 8, and we know 16 is in the 8 times table, so of course we can divide them both by 8. 24 divided by 8 is 3, and 16 divided by 8 will give us 2. So 24 to 16 can be simplified to 3 to 2. And there you are for your first ratios video.
The Force is with you, young Skywalker.